All right, hello, welcome to our lesson for today. We're going to be doing Algebra Lesson 4-1 today. We're going to be talking about how to use groups to relate to quantities. So we're going to go ahead and get started, and let's get started with our anticipatory set. Now I have to tell you, I'm very excited. I've been waiting for this lesson so that I could use this anticipatory set because I love it. I love it. So what we're going to do, there's nothing I'm going to write down. I'm going to show you a picture here in a few seconds. A few years ago, I was watching, well, what else was I watching? I was watching football and saw something that made me rewind for a second and couldn't believe it. So I decided to take a picture of it and print it out so I could have it forever. And I showed my class a couple years ago. I've showed my each class since then. Because a lot of times when you look at math, you think, how is this something that'll relate to me at some point? But you realize that there are jobs out there that use math and people make money by using these skills. So I want you to remember, now when I show you this, I'm not going to explain it, I'm just going to show you it. And we're going to go back to it at the end. But before I show it to you, I want you to realize that someone, somewhere, probably a group of people, several people were paid good money to create this. And then this thing went on television and was seen by millions of people. All right, so just remember that. Keep that in mind when I show it to you, that someone was paid money to create this. Now, this is a commercial from a couple years ago about office supplies. Okay, so as you can see, I took a picture of it so that you can still see, yes, I was watching NFL football. But this is the thing that popped up on my screen. And I believe it was Office Max. And Office Max is talking about how, oh, they're so good and you get great deals there and you can reduce your stress by going with Office Max. Where there's a elephant on a unicycle and they go around and someone was paid money to create this image. So take a second, look at it. Maybe you see it. I see it. Think about it. If you can't figure it out yet, hopefully after this lesson, we'll go back and take a look at it and you'll be able to see it. But someone was paid money, lots of money, at an ad company, and Office Max gave them money to put this on TV so that millions of people saw it. Okay, let's go ahead and move on. So, our lesson today is about using graphs to relate to quantities. On the other. So, let's go ahead and get started with what we're working on today. That is very different. Oh, you know what? I might as well, for our anticipatory set, forgot to write down. Okay, so our standard for today is F.IF.4. And it is different. We've never done this one before because now we're getting into a different topic, functions. So this is standard F, which is in the group of functions. IF stands for Intro to Functions. 4 is the fourth standard in that. Now it's a little bit lengthy, but we are going to write it down. So go ahead and follow along with me as I write this down. The standard states, for a function that models a relationship between two quantities, interpret key features of graphs and tables and sketch graphs showing key features given a verbal description of the relationship. Key features include now these are what the key features will include, okay? There are intercepts, the function is increasing, or negative, minimums, symmetries, end behavior, okay, that is it down. Let's go ahead and see what for a function. The first thing we need to know is that function. For a function, relationship. So that's what we've known before. A function is that line on a graph, the x-axis and the y-axis. Each of those represent a part. Those are the two quantities. So a function that models a we could do time, we could do miles per hour, miles on one, hours on the other, right? We do anything like that. Now, do that. I mean, the fifth graders in my class right now, that's what we're doing, things where we can see a relationship. So we're going further than that. We are interpreting key features of the graphs and tables in terms of the qualities, of the quantities. So what we need to be able to do is we need to understand what the graph is saying. So when it says interpret key features, we need to understand if a line looks a certain way, what is that telling us? We need to be able to sketch graphs when we get a verbal description. We need to sketch the graphs when we have a verbal description. If I say something was moving quickly and then slowed to a stop, we should be graph. And then the key features, now this list at the end here, key features include the intercepts, where does the x or where does the line cross the x or the y, intervals where the function is increasing, decreasing, positive, or negative, it's speeding up, it's slowing down, it slowed to a stop, it fell back to earth, anything like that. Relative maximums and minimums, it doesn't get higher than this, it doesn't get lower than this. Symmetries, it's the same on this side as on that side. End behavior and periodicity, that's if it's any of these things that we need to do, We need to be able to understand if we're let's go ahead and jump in. We don't have any language of the discipline, and we really don't have much input. We're going to get a lot of modeling in, but for input, there's one thing to remember. So go ahead and put your input, draw your flower, and we just have one reminder we need to write down for ourselves. And it says, in each situation, you must consider and imagine so that's the main thing in our input. That's what we're going to write down. Now we're going to get now when we're thinking about these relationships, there's a certain intelligence that looks for these patterns, looks for these relationships, and that's naturalistic. So our naturalistic intelligence is going to be used quite a bit when we're looking at these situations and understanding the relationships. Let's go ahead and get into our modeling. And we are going to start. Now, there are three different situations, three different ways we're going to go about looking at the modeling. First one is we're going to know how to analyze a graph. Okay, so what I'm going to do, write out the situation. We're going to go ahead and solve that situation. So the question says, the graph shows the volume of air in a balloon. As it pops. What are the variables? Describe how the variables at certain points in the graph. Okay, our question. Now I'm going to go ahead and draw the graph that goes with it, so we're able to see that and understand it as we move forward. So I'm going to go ahead and draw my y-axis and my x-axis, and then on one, this is going to be volume, and this is going to be time. Okay, so the volume of the balloon over time. Now, this graph is titled Air in a Balloon. Okay, so now you're going to watch as I draw or the reason I'm doing each thing here in a second. So we're going to start. Okay, so that is our graph. So what we need to do is explain the volume and the time and the balloon. We need to understand this relationship. So the first thing it asks is, what are the variables? The variables. Well, that's easy. The variables are just going to be volume and time. So over here, I'm going to go ahead and say the variables are volume So the volume of the balloon, the time since you started blowing the balloon. Now we understand what happened. We understand what happens because the volume in the air in a balloon as you blow it up. As it inflates, the balloon pops. So if we're looking at this, this is showing us blowing up a balloon until it pops. So the next thing we need to decide is describe how the variables are related at certain points. So first of all, we're going to talk about what are these things, because these things look the same each time. You can see that the volume increases as the time goes, and then the volume stops increasing, but the time continues to go. And then the volume increases again. Each time you need to at a certain time. Well, the volume increases each time you blow. And stays constant when you breathe or take a breath. Okay, so you blow into the balloon, the volume increases, you have to stop the balloon, stop to take a breath, you blow into the balloon, you stop to take a breath. Now you're continuing to blow into the balloon, what's going to happen at the end here? Well, at the end, right here, you see the same thing is happening, but all of a sudden, the volume immediately drops to 0. Why does that happen? Well, if the balloon pops, it can't have any more volume. So this last part of the graph that you see right here, when the balloon pops, immediately becomes 0. So we know the variables and we understand the graph, put volume into it. You stop to take a breath, you continue and continue and continue. And then the balloon is very full, you try and put more volume into it, the balloon pops and immediately you have no more volume. And that would be our graph. All right, I'm out of space here, so I'm going to go ahead and switch to the next piece of paper. And we're going to take a look at number 2. And the second thing we're going to go over, so we talked about analyzing a graph, but now we're going to go ahead and take a look at okay, so number 2 says, Mr. Barry's math videos are watched on his website. After 1, 2, 3, and 4 days. Which graph represents the data? Okay, so that's what we're looking at. People are watching my math videos, awesome. And then I see the views each day. So we need to look at a table and then decide which graph is going to be correct. So let's go ahead and start. I'm going to go ahead and draw our table. So this is the math video. We have day, and on the other side we have V. We have day 1, day 2, 3, and 4. In day 1, Barry's math. 2, the views are now at 1,011. Day 3, we have 3,400. 10,426. 26. Four different graphs. So I'm going to go ahead and write each of them up. Okay, so my four graphs are here. I'm going to label the variables on each. Okay, so each of those look the same, right? So now I'm going to put in my data points, and then we're going to see which one matches. So for A, the data for day 1, 2, 3, and 4. For C, the data points will look like this. For C, or yeah, for B now, I guess I'm going a little out of order. They look like this. They look like this. Okay. Now what we need to do is we need to look at the data over here and decide which one matches up correctly with the graph. So let's look at each one and either say, yes, this could work, or no, this does not work. So if we look, let's look at how the views change. We go from 346 views to 1,011 views. So in that time, the change is we get 655 more views. Between day 2 and day 3, we get 2,444 more views. And from day 3 to day 4, we get 6,907. So we get a bigger chunk of views each day. So now let's look. Now I see one that absolutely cannot work. All of these are getting higher except for this one. D. I think you're all familiar enough with YouTube and things like that, that you know that if something has 10 views, there's no way it can go from having 10 views to having 9 views. Doesn't make any sense. It wouldn't work like that. Okay? So D does not work. Now we have 3 more. We have to look at, go ahead and look at A. What does A say? Day 1, we would have this many views. Day 2, this many. Day 3, as you can see, it's in a very straight line, right? Meaning it would be the same rise each day. Rise each day. Come on, focus. There we go. It's a different rise each day. So it can't be A. So now we're down to B and C. Well, let's look at each one. They both seem to have a curve to them, right? This one has a bit of a curve like that, and this one has a bit of a curve like that. So let's take a look. This one, C, here, the views speed up. Here, we have this many views and then a little bit less, a little bit less. We're still getting more views, it's just not as many. This one, we have this many, all of a sudden it increases to this many, then this many. This is going to be our correct one because each day increases the number of views, doesn't decrease the number of views. So our answer is going to be B. So you need to be very careful. Looking at these graphs can be very tricky. Make sure you're understanding what the graphs are saying. Okay, let's go to our third and final bit of modeling here. In this one, we're going to learn how to sketch a graph. So once again, I'm going to go ahead and it says, Mrs. Holt and Mrs. Jones are doing crazy science things together. They build and launch a rocket the rocket rises quickly, slows to a stop. Oh, slows to a stop when it runs out of fuel. It falls quickly until a parachute opens. Drift to Earth. Sketch this graph. And label its parts. Okay, so that is our situation. Now, that's all we're going to get. We need to go ahead and make our own graph. So, Mrs. The rocket flies quickly, then slows to a stop. Okay, So every single time, we're going to write a graph. X-axis. I don't know what's going to be on them yet. I just know there's going to be. So if we're launching a rocket and looking at the way the rocket is flying and then falling, there's definitely two things I can look at. The first is definitely going to be the height. We'll say the height, the feet, right? The rocket's going up. We're measuring the height of the rocket. Now, along the x-axis, what can we look at? In seconds. We start with the launch, and as the flight happens, more and more time goes by. We'd be able to see the relationship by looking at the height and the time. Okay, now that was kind of the easy part. The next part is we need to figure out what we draw on this graph. Using blue for this. I want to actually, let's use lighter blue. It's easier to see. Okay, and what we're going to look for is what happens first. They build and launch a rocket. Okay, so it's going to launch, meaning we're going to start down here at the origin, right? It has to start at 0 seconds, and it has to start on the ground. They're not launching it from 15 feet in the air. The rocket rises quickly, then slows to a stop. So the first thing we want to talk about is the rocket rises quickly. Rises quickly. So that means a small amount of time and a lot of height. So is my line going to go off in this direction? So it's going to go like this. Then it says it slows to a stop. Okay, so it's going to. So as you can see here, the time is very short right here, but the height is a lot. Then it starts to go and it runs out of fuel and is starting to slow. So if we're labeling this now, this would be where it rises quickly. And then up here, as it slows to a stop like that, that's where it slows to the stop when it runs out of fuel. It sort of hangs in the air, and then it falls, let's see, it falls quickly until. So is it going to fall quickly until the ground? No, it fall quickly until a parachute opens. So we're not going to have this line go all the way down, but it needs to fall quickly like that. Then a parachute opens. Then a parachute opens, causing it to drift slowly to Earth. That means the time needs to be extended. It has to happen. It needs to take more time. Opening. And then it drifts on that parachute all the way to the ground where it touches the ground. So this right here would be falls slowly. So each part of the description is covered by what I've written here. The rocket takes off and rises quickly. There's not much time that goes by, but a lot of height. And then it runs out of fuel, slows to a stop. It hangs in the air, but time is still going. It's not going up or down. It's just sort of. And then it starts. Slows it so it can't hit the Earth. It needs to slow down. The time goes further and further and further. End of our lesson for today. So we're going to go ahead and stop this. Now, before I give you what your guided independent practice is, I'm going to go ahead and go back to the anticipatory set. what is wrong with this picture? Now I'm going to go back and we're going to look at it again. What is wrong with this picture? This is an actual television ad that was on TV that someone paid lots of money for, and it's wrong. It is absolutely wrong. Now, I understand what they're saying. I see stress up here, and I see cost down here. And when I look at this, I go, yeah, it looks like the stress is going down because Office Max has these $1 sales or 1 cent sales, whatever's going on, whatever. But when I look at this, I understand the relationship between variables. And my y-axis is stress, and my x-axis is costs. So while when you look at this, it looks like stress is decreasing, what does it actually say? Well, let's take a look. In the very beginning, costs are very low, right? This would be 0, but the cost is very low. Oh my goodness, the stress level is about as high as you can get. So when costs are very low, your stress is very high. But as the costs get more and more out, Office Max will go ahead and charge you a lot of money and you will have less stress. Now, obviously, that's not what they meant. What they meant, they needed to have this flipped, where if the cost is down here, the stress is down low, and it goes up as it gets more. But someone put this on TV. Someone thought, oh yeah, that shows what we're talking about, when it's absolutely wrong. It shows the let me zoom in for you. Let's go ahead and talk now. We'll get our guided practice. And our guided practice is going to be our PPSE, and you're going to do number 15. Oh, I'm sorry. No, you're going to be doing number 5. Number 14. You can do number 14 as well. Once you're done with that, you can go ahead to your independent practice. And your independent practice will be the lesson 4-1 quiz, which is on your Pearson portal. And I believe it's only 2 questions. So take your time with that. That is your work for today. Good luck and go Buffs.